Hello everyone, I am Dr. M. Shivashankar. The purpose of my channel is to deliver the core concepts in thermal engineering. With this note today I will explain about the stages of combustion in SI engines. Yes, so the complex combustion event inside the spark ignition or gasoline engine into three stages. Okay, the stages which I have explained it in different colors. The first stage is called as ignition lag, and second stage is called as flame propagation, and third one is afterburning. So it is crucial to optimize the engine performance, efficiency and emissions. Let's look at this first stage. The first stage is called as ignition lag. So the ignition lag is a preparatory phase. After the spark plug fires, it doesn't cause an immediate combustion. Instead, a small kernel of flame develops and grows until it becomes stable enough to propagate. This stage is called as ignition lag. And this is the period for smooth engine operation. If this is not proper, then engine operation is also not proper. So the period of ignition, which is shown in the path A to B, is called as ignition lag. After the spark is fired, the ignition lag lasts about 10 degree to 35 degree before top dead center. This is depending on the engine speed and load. If the speed and load is varies, this ignition lag timing also going to vary. Okay. So the duration of the ignition lag affects the combustion stability. If it is too long, okay, it can lead to a rough running of an engine. And more critically, a long delay allows the unburned end gas inside the combustion chamber. It may overheat and making engine prone to knock. So in this stage, further as mentioned in the slide, 10 percentage up to 10 percentage of the fresh charge is burned in the flame development period. A ignition lag of 0.0002 seconds corresponds to 35 degree of crank rotation when the engine is running at 3000 rpm. If the engine is running at 6000 rpm, this seconds is further going to be reduced. Okay, how this second is going to be calculated? That is very interesting phenomena. Let me explain that. Now here, for example, For example, here which I have said to you, the engine is running at uh, 3000 rpm, right? So 3000 rpm. So 3000 rpm, that we have to convert it into seconds. Okay, so for that 60 divided by, so here the rpm is 3000. The rpm is at 3000, and what for we have going to calculate. Okay, so we are going to calculate for that 10 to 35 degree of crank angle rotation. Okay, so into 3000 into 360 degree, so which will give an answer about 0.0002 seconds. Okay, yeah, so let me explain about the second stages of the combustion in SI engine. The second stage is called as flame propagation. It is the heart of power generation. Okay, where the complete burn will takes place nearly. Okay, a fast and stable complete burn here the maximize the force of the piston and leading to a high power and thermal efficiency. So here turbulence in the chamber is key to speeding up this stage. So in this stage of flame propagation, the established flame front travels rapid across the combustion chamber and compressing the bulk of the air-fuel mixture. This is where the most of pressure rise occur. So if we see from point B to C, the pressure rise is maximum. Okay, so the flame propagation, the second stage, is follow the path B to C. So the B to C is a steep curve. Okay, so this period of flame propagation will take place about 10 degree before top dead center to 20 degree after top dead center. So this chemical process, depending upon the nature of fuel, temperature and pressure and the proportion of exhaust gas, which means the end gas, and the rate of oxidation. So here up to 90% of the fresh charge is going to be burned in this period. Now let's look into that third stage, sorry. Here the last stage of combustion is called as afterburning, which means the remaining mixture, often in the crevices, the area of the chamber, are consumed and it is burned. This stage must be carefully managed as it impacts the exhaust emission and efficiency. So it happens as the piston is descending, so it creates lower pressure obviously, and minimizing this stage through a good combustion chamber design and mixture motion reduces the energy waste, and it also lowers the hydrocarbon and carbon monoxide emissions that results from the incomplete combustion. So today we have discussed about the combustion in SI engines. So in the next subsequent videos we will discuss further. Thank you.